Hello, everybody here. First of all, I would like to thank for this opportunity to present the results that we have here. So everyone probably agrees that the water quality for hydroponics, aquaponics is very important. So here I'm going to talk about exactly that. So I'll cover the aspect of water toxicity reduction. So I'll elaborate a little more about what it is, what it means in hydroponic system. So as we probably know, there are many different kinds of diseases. For example, in basil business, there's different kinds of oomycetes, and that is a picture of the basil downy mildew, which is very classic. Some others in here, a lot of them are just fungi, some other eukaryotes. For tomatoes, you have fungi, oomycetes, and that is a picture of tomato leaf blight caused by this phytophthora here. So, and in an aquaponic hydroponic system, and most likely people use a recirculation pattern to reduce the cost. And when you recirculate the water, so you may concentrate the pathogens inadvertently. So it is very important to disinfect the water. And this concept has been stressed many times during this workshop. So different disinfectants differ in their potency to the same pathogens. And for example, this is the example of Xarium oxyporum. That's a fungi here. In order to get 99% of these pathogens killed, you can use bleach. You need about 1.5 minute of contact time, 8 milligrams per liter of this substance. And for another chemical, ozone, you need much less dosage here to get the same level of kill. And very similar in idea, different pathogens, they differ in their resistance to the same disinfectant. And here, I'm just using ozone as an example here. And for example, the same pathogen, Xarium oxyporum, to get about 99% killed, you need about 2 milligrams per ozone for 4 minutes. And another plant root rot pathogen, phytophthora, to get 99% of these pathogens killed, you only need much less ozone. So it's very pathogen and disinfectant specific. So the message here is, because of this specificity, it is very important to study the inactivation of these pathogens, because by doing so, we can pinpoint the exact dosage for your farm so that you can save your costs, so you don't overdose your system. So when we disinfect the water, as I was saying, the toxicity of the water may actually increase. So what does that mean? So that basically is a result of inadvertent reactions between the disinfectant and many components in the water. For example, the organics that you apply, some of the nutrients, different disinfectants. They can all produce toxins in water inadvertently. So, and some of these toxins, organic toxins, may be uptaken by some of these produce, affecting the produce quality. So we have to be careful with this. So that's why in this talk, I would like to talk about the toxicity of this treated disinfected water here. So there are many disinfectants out there commercially. For example, as you have just said, hydrogen peroxide based, peracetic acid based, bleach based. Some of you may be familiar with some of these brands here. Today, I'm going to talk about more traditional, the chlorine versus a relatively newcomer to the aquaponic hydroponic system, the ozone technology. So chlorine bleach is a benchmark technology that many of us are familiar with. It's effective against a very wide range of pathogens. I don't expect you to read all this, but the point is it's effective against a very wide range. But some of them, you need very high dosage of chlorine, so high that it may be damaging the roots of your plants. So ozone is a powerful disinfectant. It's even effective in cold water. It is self-destructive. It does not leave a residual in your water, and it's even effective against several chlorine-resistant pathogens. For example, this Fusarium oxyporum, you need much lower ozone dosage compared to chlorine to get this pathogen inactivated sufficiently. So ozone is typically applied into the system as gas bubbles. So the specific presentation objective is to compare the more traditional technology, the bleach technology, versus this newer ozonation technology in terms of the toxicity of the water that has been treated by these technology. That is the goal here. So typically in a hydroponic system, when we look at chlorine, we typically just inject chlorine into the system, so either a pump or just directly dump chlorine into your system, and then the water is fed to the plants. And for ozone injection, and typically we would have this kind of interior injector here, and it's very cheap. This typical model I found on Amazon is only $38. So, and what you need to have is an ozone generator, and that ozone generator passes the ozone to this injector. So this basically injects gas into your distribution line, and this ozonated water can go downstream to different applications such as aquaponics, hydroponics, aquaponics, some of different other operations here. So speaking of the ozone generator here, and if you are interested, this is a traditional ozone generator. So in order to have a lot more ozone produced, you probably need a big ozone generator, and it is probably very energy consuming. And what's available these days is a new technology called the microplasma ozonation system. It's much smaller and very light in weight, highly efficient, and this is what we've been using in our system. It saves electricity and gets the job done. So just really quickly. So what I did was I did similar experiment. I ozonated the water, or I chlorinated the water, or I bleached the water. Then I put this water together with some mammalian cells, and these cells came from the hamster here. And so the question I wanted to ask myself was, if this combination will be toxic to the cells or not. So as simple as that. So what we saw was ozone-treated water was actually less toxic than the bleach-treated water here. So if you look at here, the vertical axis, the higher you go, for the top panel, and same, at the bottom panel, the higher you go, the more toxic it is. So the top panel is one source of water, hydroponic water, and the bottom source is another source of water. So this left white bar represents, these bars represent the control without any treatment, just raw water standing there. And this central panel represents the ozonated solution, and this bleach treated water right here. So you can see the ozone-treated water was much less toxic than the bleach-treated water. Same with this situation here. And for example, in this case, bleach-treated water was much more toxic than, say, the non-treated control here. So another finding we had was the low disinfectant dosage combined with long disinfection contact time was actually way superior in terms of toxicity reduction than, say, high dosage versus combined with short contact time. So as you can see here, so these are again two sources of waters, two different panels. So when you have low dose paired with long contact time, and you in general have lower toxicity, and this is true for both ozonation technology and bleach treatment technology. So the take-home message from here is that lower disinfectant amount, longer contact time is superior than a huge blob of disinfectant dosing at the same time. So what does this actually mean, and how is this relevant to actual practice in a hydroponic system? So instead of just one dosage of disinfectant at one single point, where you have this huge amount of disinfectant into your system, what you can do is you can split up this amount of disinfectant over several injection points, and that's all you need to do. So if you don't have the capacity to have extra piping and all that to extend the contact time, then that's fine. You just inject it into several ports. So and also at the same time, because you're applying lower dosage, it's actually healthier for your plant roots. It's less damaging to the roots of the plants. So this is true for both ozone technology and bleach technology. So this is kind of out of place, this slide here, but we thought this was important to share with everyone here. So we look at several of these farms here, and so the good news is we did not see any foodborne pathogen, no E. coli whatsoever. So we did this using the state-of-the-art 16S sequencing technology. So no foodborne pathogen, no E. coli, no salmonella, no listeria, and none of those pathogens. So that's great news. And what we saw was some of these common opportunistic pathogens. As Brenna was saying, these opportunistic pathogens are probably okay for people with a regular immune system, but people with a compromised system, they probably need to be more careful with it. So what we saw was Pseudomonas, Mycobacterium, and Legionella. Legionella probably could be a potential risk if the water is sprayed, and it could be a risk for hydroponic, aquaponic workers. So, and therefore, I think one of the messages is to disinfect the water, circulation water, and that's very important.
Excuse me, I'm sorry to stop you. Are you saying that you're seeing Legionella, for instance, in farm waters?
Exactly. Yeah. So Legionella here is not the disease-causing Legionella haemophila. Yes. So it's just Legionella. So
this is just a general test of water. This isn't like where specific disinfecting regimes have been used. This is just you went out and tested farms and found it in those farms.
Exactly.
Thank you.
Yes, and it is not down to the species level. Yes. So the summary here is, in general, ozone technology lowered the toxicity compared to the bleach technology. And also, for both ozone and bleach treatment technologies, the ideal way to reduce the potential toxicity in this water is to use low dose and long contact time. Thank you for the attention.
Go ahead.
How does, have you looked into the effects on beneficial microbes of the low dose, long contact time?
So here, I would like to just clarify. So we were not specifically looking at the inactivation aspect. So we did not track any microorganisms in the system, be it beneficial or pathogens. So because these dosages that we used were known to be not harmful to the plant roots, and at the same time effective for certain plant pathogens, and that's why we chose those dosages. But unfortunately, I could not tell you their effect, but I'm assuming they probably will also inactivate some of those beneficial microorganisms at the same time.
How are you quantifying toxicity then?
Yes, that's a good question. So, so what we did was we had to concentrate the water through a solid phase extraction, and we basically put the extract of this water together with those cells that you saw, and then we basically counted how many cells are left after a certain contact, and then we would produce this kind of sigmoidal S-shaped curves. Then we would use the concentration of this water that would produce about 50% kill of these cells as a metric.
Okay.
So
this LD50.
Yeah, LD50.
Thank you.
Are you measuring the, for instance, the chlorine additive itself as toxic, or are these byproducts of the presence of the chlorine that's reacting with other things in the water, and that's what's creating the toxicity.
Byproducts.
Okay,
Yes, byproducts of chlorination.
just a wide range of
Yes, wide range of
secondary, tertiary.
disinfection byproducts. Yes, and some of those byproducts may circulate back depending on your configuration of aquaponic, hydroponics.
It can concentrate, yeah.
Yeah, fish or plants. So
What was you showed the two different systems for ozone gas generation.
Yes.
Can you give any idea of the general cost differences between the larger system, which I'm assuming is very, very expensive, versus the microplasma generator?
Here I'm just trying to make a big exaggeration here. It just to show because 600 grams per hour. That's for industrial wastewater treatment. You don't need that much. So here I would go on a limb and say probably a regular ozone generator about this size is what you need. And you don't need that much output. And each of those generators is probably hundreds of dollars.
Oh, okay.
Yeah, and the technology is very reliable these days. So you rarely have a breakdown.
So hundreds of dollars versus
Hundreds of
thousands
dollars or thousands, depending on the models, depending on adjustability features, things of that nature. And also similar with
Yeah,
this.
there is a company that making it. I try to invite them to come to the electricity
Okay.
next time.
Yeah.
Because of the shop notice.
And I mentioned UV treatment in my introduction. Those models, depending on the flow rate, are in the magnitude of upper hundreds to 4-digit thousands, depending on the flow rate that you need. Just to give you an idea of.
We can present also UV next time too.
Yeah, but the UV thing is UV. You have to have a clear water. You can't have suspended solids, which
Right.
is
Yeah,
very hard
that's
to minimize in a lot of these systems. You just have suspended solids.
Right. So you have to have inline filtration before.
Yeah,
The
and
UV
when you
system.
have extra step, which is like such as filtration, you may clog the filter, and you have to invest in extra time and money to clean it up or even replace it. So with ozone, it doesn't have that problem. Although it may have some problems, such as some of those big flocks, the ozone just can't get inside. But if you get a big flock, any disinfecting technology will have a hard time.
Right. But ozone isn't affected like the same way bleach parasitic would be in terms of the organic load efficacy, because the higher the organic load, the less effective. Ozone's better at that than bleach.
Yes. It's the same.
UV cannot go deep into water. That's a problem.
I'm sorry again. What injection rates like of ozone are people using for efficacy? Like how many grams per
Yes.
liters or whatever.
So depending on your target pathogen, for more resistant pathogens, you need, and also depending on the water quality, as Zach was saying, the higher organic loading you have, part of this ozone is consumed when you have organics in your system. So and that part of the ozone is not going to be wanting to react with your pathogens. So higher organic loading, probably you would need higher ozone. But I mean, generally, 1 to 2 milligram per liter.
Milligrams.
Yeah, milligram per liter.
But you still have to be careful for the toxicity of the ozone on the plant, or to the roots.
Yeah.
Do you know what level is toxic to plants? Ozone?
Yeah, we saw several
0.5.
0 point something. It's below ppm. A good thing about ozone is you don't have to do much about ozone for it to disappear quickly. So you can design your system very easily. It's just a pipe. You can inject ozone in one end, and if you do the dosage correctly, at the outlet of the pipe, you don't have ozone. So it's not damaging to your
And
plants.
it's staying in
Yeah,
there.
so outlets.
So in this pipe, it's like your reactor, but it's called a reactor. It's just a pipe. But chlorine, it just stays in your system much longer, and you may run into some problems with that.
Or
Then
even you
another
can use
problem
it.
with the ozone is it breaks down the organics. it breaks down the organics in the system, so it's like a low organic myself as a food for beneficial bacteria.
Even you can use it before the fish, because fish can tolerate ozone, and even it's good for the fish. Some application I saw that the fish become happy with it.
I'm not sure.
Do you know how ozone affects any of the nutrients that could be in the water?
What kind of nutrient?
Nitrogen, potassium.
So, for example, you do not have to worry about ozone oxidizing the ammonia because for the regular residence time of water in your system, ozone will oxidize a little bit, but it's not significant enough for your concern. Ozone will oxidize some of the organics if you're applying some of that to the system. And it will just break it down into smaller chunks to make a bite size for the plants. So it has that. Ozone has a unique property of called microflocculation. So if you have iron in your system, well, in most systems they have a small nutrient, a small amount of iron, and if you circulate it, it may create slightly larger flocks. But those are just that's a more minor system, a more minor effect.
Okay, well, if there aren't any more questions, do we get a round of applause?
Yeah, thank you.